Alright, this is the video lesson for 7-3, elimination using multiplication. Again, we are still talking about systems of equations, so we're dealing with two equations or two lines graphed on the same coordinate plane, and we're trying to find where those two lines cross, that place where they cross being the one solution that we're dealing with. Keep in mind that there can be no solutions if the lines are parallel, or there can be infinitely many solutions if the two lines are right on top of each other. Anyway, in this case we are using the elimination method, but the elimination method using multiplication, meaning that I still want to add these two equations together, and when I add them together I want either the x's to cancel or the y's to cancel. But in this case it's not going to happen because with the x's I have a 2x and a 3x. Well, that's never going to make 0. And with the y's I have a 1y and a 2y, and that's also never going to make 0. So what you need to do here is you are going to multiply either just one or both of the equations by a certain number in order to make the x's the same number or the y's the same number. So in this case the easiest thing to do would be to multiply this first equation by a 2, because that will turn the y into a 2y, and now my y's are the same. So this is what we're going to do. We're going to multiply the top equation by 2, and when you do that you have to distribute the 2 to every piece of the equation. So I am going to have 2 times 2x gives me 4x. 2 times y gives me that positive 2y. And then 2 times 23 gives me 46. The bottom equation then we're just going to leave as is. I'm just going to rewrite it here. 3x plus 2y equals 37. So now you have two equations here that are ready to be eliminated, except again in this case we cannot just simply add the two equations together, because adding them together will not give me a 0 there. It would give me a 4y. That's not what I want. I want 0 y's. So I'm actually going to have to subtract these two equations. And again, if you remember what we talked about in the last section, subtracting is the same as adding the opposite. So I'm going to change it into addition and change all the signs. Now what you have is you have 4x minus 3x, which is just 1x, 2y minus 2y, which is 0, so that just cancels out, and then 46 minus 37, which is what, 9? So you have x equals positive 9 as your first answer. And then again, to find your second answer, or to find out what your y is, you plug that 9 into either of these two equations in place of the x value. I'm going to use the bottom equation right now since it's just right there, and my bottom equation now says 3 times 9 plus 2y equals 37. Well, 3 times 9 is 27 plus 2y equals 37. I'm going to then subtract 27 on both sides. 2y equals 10. And then last step is to divide by 2. So y equals 5. So there are your two solutions. X is 9, y is 5, which means this is a one solution system, and that one solution is 9, 5. So again, it is elimination, but it is elimination where you have to multiply either one or both of the equations to get the numbers the same so that they can eliminate. So let's look at example number 2 now. Now again, when I say that you could multiply both equations by something, if you look at this first problem, or if you look at problem number 2 here, if you wanted to make the x's eliminate, you could turn them both into 15x's by multiplying the top equation by 5 and the bottom equation by 3. And that's perfectly fine. In some future problems here, we'll have to do that. But that wouldn't be the easiest way to go about this problem, because in this problem, when you look at your y's, you say, okay, 4y and 2y, I can easily make those the same by multiplying the bottom equation by 2. So, multiplying this bottom equation by 2 is going to turn this into a 4y. Now, you might also think that, well, yeah, I'm going to have a 4y, but technically I want this to be a negative 4y because I want positive 4y and negative 4y to cancel out. So if you want that to be a negative 4y, what you can do instead of multiplying by 2 and then coming back and subtracting is to just multiply the whole equation by negative 2. And that's what we're going to do here. So we're going to multiply everything in here by negative 2. That's going to give me negative 10x minus 4y equals positive 8, because negative 2 times negative 4 is positive 8. And then the top equation, again, we did not need to change that one, so that one stays the same. 3x plus 4y equals 6. So, now you can see here with these two equations, you're going to have this positive 4y and negative 4y cancel out right away. Now, you might look back at the last problem here and say, well, shouldn't I have multiplied by a negative 2 back there? And yes, you could have. You could have multiplied by a negative 2. We didn't. We multiplied by a positive 2, but that means we had to subtract when we got to this stage right here. We had to subtract the two equations instead of add them together. And when we subtracted, we changed it to add the opposite. So in this problem here, you're simply saving yourself the subtracting or adding by the opposite step by multiplying by a negative 2. Because now, as you can see, this problem's ready to go. We can just add these two equations together. 3x plus a negative 10x is negative 7x. 4y minus 4y is 0. And 6 plus 8 is 14. Next step is divide by negative 7, and you get x equals negative 2 for your first answer. Plug that negative 2 back into one of the original equations. Again, I'm going to just use the bottom one here for convenience purposes. So I have 5 times negative 2 plus 2y equals negative 4. 5 times negative 2 is negative 10 plus 2y equals negative 4. Again, you're just going to solve this at this point. Add 10 to both sides. 2y equals 6. And last step, divide by 2. Y equals 3. So, here you go. You have, again, a one solution answer. And that one solution is negative 2, comma 3. Meaning the two lines, these two lines up here that cross, they're going to cross at the ordered pair negative 2, 3. Not. So that's exactly where the two lines intersect at. Alright. The next two problems, again, we're going to do a couple where we have to, sorry about that, where we have to multiply both equations, and you can see that right away with problem number 3, because you're looking at a 4x and a 3x. Well, there's nothing that I can multiply just one equation by to make those equal. Same with the positive 3y and negative 5. I can't turn the 3 into a 5, and vice versa. I can't turn the 5 into a 3. So you're going to have to multiply both equations. Now, what you do want to look for in this problem is there anything that already has opposite signs? And that's true. You have a positive 3y and a negative 5y. So let's go ahead and try to cancel those numbers. In doing that, we're going to have to multiply both equations by something. So if you look at these two numbers, you say 5 and 3. Well, I can turn both of those into 15s. Okay, and that's what we're going to do. So we're going to take this top equation, and we're going to multiply the whole thing by 5. And we're going to take the bottom equation, and we're going to multiply the whole thing by 3. And this is what happens. Top equation, I distribute, and I get 20x plus 15y equals 40. And the bottom equation, I distribute the 3, I get 9x minus 15y equals, what is that, negative 69. Alright, so you have changed both equations, and in doing so, you made these 15y's opposites, positive 15y and a negative 15y, so these should be ready to cancel. I'm going to add the two equations together. 20x and 9x makes 29x. Positive 15y and negative 15y is what cancels out. 40 and negative 69 makes negative 29. Should be an easy solve here. Divide by 29, and x equals negative 1. So there is your first answer. X is negative 1. Again, same as always, plug it back into one of the original problems. I'm going to use the bottom one again. So I'm going to say 3 times negative 1 minus 5y equals negative 23. 3 times negative 1 is negative 3. Add 3 to both sides. Negative 5y equals negative 20. And divide by negative 5, y equals positive 4. So, again, I get a 1 solution answer, and that one solution is negative 1, 4. Alright, why don't you try the next one on your own by pausing the video. Okay, and on this last problem here, again, we want to make something eliminate. I could turn the x's into 6's, because 2x and 6x could both be multiplied to make 6x, or I can turn the y's into 12's. I'm going to pick that only because the y's already have opposite signs. You have a positive 4y and a negative 3y. So I'm going to try to turn these both into 12's. So I'm going to multiply the top equation by 3 and the bottom equation by 4. This is going to give me 9x plus 12y equals negative 75, and I'm going to get 8x minus 8x minus 12y equals 24 for the bottom equation. So again, since I turned the two numbers that were already opposites into the same coefficient, I can now add these two equations. 9 plus 8 is 17x. Positive 12 and negative 12 cancel. Negative 75 plus 24 makes negative 51. And last step here into solving would be to divide by 17. So x equals negative 51 divided by 17 is negative 3. So take that x equals negative 3, plug it back up into one of the original equations. Again, I'm going to just use the bottom one there. I'm going to say 2 times negative 3 minus 3y equals 6. Negative 6 minus 3y equals 6. Add 6 to both sides. Negative 3y equals 12. Divide by negative 3. And y equals negative 4. So there you have it once again. We got a one solution system, and that one solution is negative 3 comma negative 4. Done. Alright, very good. So that's the gist of solving using multiplication, which is that you have to change either one or both of the equations so that two of the coefficients can cancel, essentially eliminating one of your variables. So there you have it. The next thing we're going to do with this video is do a little review of the last 3 things we've dealt with, and that was substitution, elimination using adding and subtracting, and elimination using multiplication. These are all 3 perfectly good methods to use to solve a system of equations. Again, another good method would be to graph. You can graph the 2 lines and try to see where they cross. Unfortunately, sometimes you will not be able to tell, or the fact that they cross at such a weird place like negative 48, negative 82, you don't want to graph that. Okay, so again, the 4 methods to solve a system of equations. The first being, graphing the 2 lines. Again, if they don't cross, you get a no solution answer. If they do cross, you got to tell me where they cross. This is a one solution system, and that point where they cross is the one solution. And then the other possibility is if you have a line and then what I say another line right on top of it, which essentially means you have another equation that is the exact same line. That answer is infinitely many solutions, because they always touch. They touch, right here, right here. They're constantly touching. There's infinitely many solutions that where the 2 lines cross, or ordered pairs that work for each equation. So I'm going to give you a little guideline to go by here on when to use what method. The best time to use the substitution method is it when you already have an equation that says x equals something, or if it says y equals something. Because again, if you already have x equals something or y equals something, that something, whatever it is what you can use to substitute into the other equation. So when x equals something or y equals something, pretty much when you have x or y all by itself in one equation, I should probably add that to that. This is for in one or both equations. If that's the case, you're ready to use substitution. Next method is elimination by adding and subtracting. You'll use that method when you have the same coefficients. And again, that's the same coefficients for obviously the same variable. So you can either eliminate the x's or the y's, and you will add the equations together if they already have opposite signs. And you will subtract if the two equations, or if the 2 variables that you're trying to cancel have the same signs. And finally, elimination using multiplication. You'll use this method when you have no coefficients that are the same. Alright, so here are your 3 examples. Again, we've done all this, so you should probably try these on your own and then just double check and see if you got them right by pausing the video and then playing it to see if you did them correctly. Okay, here we go. Number 5, if you notice this problem, you do not have anything that says x equals or y equals right off the bat, so that eliminates substitution. You also do not have the same coefficients for the same variables. You have a 4x and then a 1x. You have a negative 3y and then a positive 2y. So this means that we're going to use elimination. I'm going to write this above. I'm going to abbreviate things. Elimination using multiplication. Little parentheses there is for multiplication. So we're going to solve this one using elimination with multiplication. So what are we going to multiply by? Well, I'm going to cancel the y's here because they already have opposite signs. I'm going to turn both of them into 6's. I'm going to do that by multiplying the top equation by 2 and the bottom equation by 3. So the top equation turns into 8x minus 6y equals 24, and the bottom equation turns into 3x plus 6y equals 4, 8, 12, 42. So we are ready to solve. I just realized that I actually could have eliminated the x's pretty easily by just multiplying the bottom equation by 4. So again, that's definitely something that you could have done. I went with the y's instead. It should all work out in the end. We should get the same answers. I'm going to add these 2 equations together. 8x plus 3x is 11x. Positive 6 and negative 6 cancels. 24 plus 42 equals 66. So again, this ends up being a nice easy problem. Divide by 11 and you get x being 6. Plug that answer into one of the equations. I'm going to use the bottom equation there, so I have 6 plus 2y equals 14. I'm going to subtract 6 on both sides. 2y equals 8. Last step to divide by 2, y equals 4. So you have a one solution system, and that one solution is 6, 4. Done. Alright, very good. Hopefully you've already tried all the other problems, so I'm going to just move right along to them. Number 6, this is going to be a nice one to use substitution because the bottom equation says y equals. And in this case, it says y equals x. So I'm going to just plug x in place of y, turning my first equation into 4x minus 4x, or I'm sorry, 4x minus 2x equals 14. And again, you just plugged in x in place of y because it says x equals y. And now we solve. 4x minus 2x is 2x. 2x equals 14. We're going to divide both sides by 2. And x equals 2. Plug that 2 in for this equation. Makes this equation pretty easy. It says y equals 2. And there's your solution. One solution again. In this case, 2, 2. I think I made a mistake. I did. Sorry about that. Let's back that up. I did a very basic math mistake right here. 14 divided by 2 is not 2. Don't know why I was thinking that. Put that 2 in my head. 14 divided by 2 is 7. That changes our answers. So x is 7. Go back and say y equals 7. which changes my answer. It is still a one solution problem, but my one solution is 7, 7, not 2, 2. So one solution, 7, 7 is where those two lines cross. Alright, and again, I just realized that by going back and looking at some of my work there, and I saw that I had for some reason written 14 divided by 2 is 7, or is 2. That's obviously not right. 14 divided by 2 is 7. And again, that's just part of checking your work. You know, go back through those steps, make sure you didn't make some silly mistake with your signs or just a basic math mistake there. Alright, and our last problem, number 7. This is going to be one, let me go back to number 6 and write above the problem substitution, because that's the method I used. And then on the last problem, you look here and you say, hey, I have a -3 and a +3. That's ready to cancel out right away, so I must be using elimination with addition or subtraction, because I don't have to multiply anything. I don't have to change the coefficients of anything. They're just ready to cancel out. I'm going to just leave that cancel out bar there because they canceled by just adding them together. Everything else, 2x plus x gives me 3x. Again, the -3y and the +3y just canceled, and 12 plus 12 is 24. So this will be another quick problem here. Divide both sides by 3, and x equals 8. Now take that 8, plug it into one of the equations. I'm going to just plug it into the bottom equation again. And that bottom equation now says 8 plus 3y equals 12. And we'll solve this. Subtract 8. Subtract 8. 3y equals 4. Last step will be to divide both sides by 3, and y equals 4/3. Again, I'm going to just leave it like that. You could obviously say x equals 1 and 1/3. That would be fine also. I'm just going to leave it as 4/3. Again, meaning that this problem has one solution, and the solution is 8, 1 and 1/3. Again, 1 and 1/3 or 4/3, both is fine. I used both at different times here. But again, fractions are fine. That's where the two lines cross, 8, 1 and 1/3, which is another reason why we do this other method, because it would be very hard to graph the two lines and see that they cross right at 1 and 1/3 without actually doing it algebraically. So there you go. A little review of all three methods to solving a system of equations besides the graphing method. I hope that helped. Make sure you're asking your teacher questions in class. Thank you.